Hello and welcome to my laboratory. Here I'm experimenting a little bit with the Laser Saber Super Looper circuit. With a couple of modifications, and I want to demonstrate some interesting effects that I found. First, let me just describe what's going on here. I guess you can see that it's actually working right now. This is a loop stick variable inductor here with a ferrite core, and it originally has just a single winding on it that looks like this. This is actually just one winding. It's one coil and then another coil in series, and this is a Litz wire, multi-stranded conductor on there on that loop stick. So what I did was I took an ordinary loop stick. Its main Litz wire coils are terminated in these two little ears here, and I wound two extra coils on top of it. I took this heavy magnet wire here and I wound one layer of 20 turns on top of the Litz wire coil, and then I potted that in epoxy, and there are its two leads. And then over the top of that I wound about 100 turns of this thinner magnet wire here, and it's not connected right now, not yet. So I have the 20 turn coil and the Litz wire coil wired as the two coils in Laser Saber's circuit. There's the 10 megohm base resistor there. There is the MPSA 18 transistor emitter base collector, and there are the three series LEDs, red, green, and blue. And here's a capacitor. Instead of the capacitor he used, I'm using a 1 farad capacitor there, and it's hooked up across these two little pins where the Laser Saber capacitor is normally hooked up, and this is where I will be feeding power into the circuit when I charge the capacitor. And then this over here, this is just a push button switch and a bleeder resistor hooked across the capacitor, so that by pressing that I can discharge this capacitor in a controlled manner down to some desired voltage, or all the way if I want to. And I've been pressing it, so you can see that the LEDs are out now. Okay, so let me get the voltmeter here. So the voltmeter is on the 2 volt scale, and let's see, it's minus and plus. Alright, so that capacitor is down to about 0.45 volts, and it's slowly recovering a little bit of voltage, and obviously that's not enough to oscillate to make the LEDs go, right? So here, what I have here, this is a little 3 volt button cell. It's a CR2016 3 volt button cell, and this is its holder here. And this thing is, I've been using this for days. It's pretty depleted already, but this is what I use to charge up. Get back in there, just a piece of heat shrink to keep it from short circuiting. So here I'm going to apply this depleted button cell to the input voltage connection here, and we'll watch that battery charge up, or rather watch the capacitor charge up there, and you can see that the LEDs are pretty bright, reasonably bright, not brilliant, but bright enough to tell that they're bright. And let's see here, change ranges. I don't really want to go on too much voltage here, so I'll disconnect that battery now. And now you can see that the LEDs are glowing and that the voltage is dropping slowly. So I'm going to discharge some of that voltage by pressing my bleeder button, try to get it down to just below 2 volts so I can use the higher resolution scale. Okay, so now I think you can see that the voltage is holding and it's only going down very, very slowly and keeping those LEDs to reasonable brightness. Now when I vary the inductor in there, not much happens. In fact, I don't see any change in the brightness or the voltage decrease rate on the LEDs. Okay, so that's with the 20-turn coil acting as the sort of primary of the Joule thief circuit. Okay, so now what I'm going to do is make some changes. If I can do this live on camera. So I'll just disconnect the that 20-turn coil like that. And now instead of that, we will connect that outer 100-turn coil in the same place where the 20-turn coil was connected, live on camera while under power. You think this is easy? Okay, so now I've got the outer coil connected where the first coil was connected, and I think you can see that the lights are a bit brighter now, and we still have this low current drain, low voltage dropping there. Okay, now I think, let's see, there's still no or very little change in what happens with the position of the core of this inductor going down in there, right? Okay. And those lights are fairly bright. So I'm going to press this button to discharge the voltage a bit. Try to get it down to around 1.5 volts, 1.4 volts or so. Okay. So you can see that the lights are pretty bright. There's not much change in the brightness of the lights with the position of the inductor core, but there is some. Now what I'm going to do is take one of the ends of that 20-turn coil and hook it in right there. And now, I don't know if you can see that or not, now there's a position of the inductor core. Let's see if I can get some of that voltage off of there again. Wait a minute. With just one end of that coil hooked up, of that extra coil hooked up, now I have a situation where moving the moving the inductor core, you can get to a point where those LEDs are really, really bright. Discharge some more of the voltage here. Get down to about 1 volt or so, just over 1 volt. Now by varying the position of the inductor core, you can see that we go through some cycles of dimmer and more brighter, dimmer and more brighter. That's just with one of those 20-turn wires hooked up. If I hook up the other one, while moving the position of the inductor, I can find little resonant peaks where the LEDs get really very bright. Hooking up both of those wires doesn't do it. Hooking it up to the wrong side just kills the LEDs totally. But if you hook it up to the right side, you can find these really bright zones like that, and you're still getting a really slow discharge on the voltage. So here I'm moving the core of that inductor in and out with the 20 turn winding just hooked up with one wire to one side of the Litz wire winding. The other side of that inductor is free over here, or rather that 20 turn winding is just out here. And by moving the core to the right spot, you get some pretty darn bright LEDs, and you still have a really slow discharge rate. Alright, thanks for watching.